Hi students, welcome to Mohan School of Maths. Today we are discussing some problems from previous year's question paper. Okay, from matrices and what determinants. So we can move to the class. It's me Mohan. So we can start the first question. For the symmetric matrix A is equal to matrix 2x4, 5, 3, 8, 4y, 9. Find the values of x and y. The B part, from part A, verify A into A transpose and what A plus A transpose are symmetric matrices. This question from 2019 March. Okay, see the first question. For the symmetric matrix A, 2x4, 5, 3, 8, 4y, 9, what is the value of x and y? Okay, given that the matrix is what? A symmetric matrix. So what is symmetric matrix? The rows and columns are what? Same. If you interchange the rows and columns, the matrix will not what? Change. That means A transpose and A are what? Equal. So it is very clear that the value of x is equal to what? 5 and what? The value of y is equal to what? 8. Because from the first row 2x4 and first column 2, 5, 4. So surely what? X is equal to 5. And see second column. What is second column? X, 3, y. And what is second row? 5, 3, 8. So surely y is equal to what? 8. So x is equal to 5 and y is equal to what? 8. Okay. So the matrix A. What is the matrix A? The matrix A we can write A is equal to 2, 5, 4 and what? 5, 3, 8 and what? 4, 8, 9. This is what? Matrix A. Because x is equal to 5 and what? Y is equal to 8. Now what is the second part of the question now? Verify that A into A transpose is what? Symmetric and also what? A plus A transpose also symmetric. Okay. We can do the second question. So the B part, A into A transpose. We have to what? Verify that what? A into A transpose also a symmetric matrix. So A into A transpose equal to what? This is A and this is what? A transpose. So multiply the first row with the what? First column. 2 into 2 is what? 4 plus 5 into 5 is what? 25. 4 are what? 16. Then first row with the second column. 2 5s are 10. 5 3s are 15. 4 8s are what? 32. Then first row with third column. 2 4s are what? 8 plus 5 8s are 40 plus 4 9s are what? 36. Then second row with the first column, 5 2s are 10, plus 3 5s are 15, plus 8 4s are 32. Then 5 5s are 25, 3 3s are 9, plus 8 8s are what? 64. Then second row with what? Third column, 5 4s are 20, plus 3 8s are what? 24, plus 8 9s are what? 72. Now third row with what? First column, 4 2s are 8, plus 8 5s are 40, plus 9 4s are 36. And what? Third row with what? Second column, 4 5s are 20 plus 8 3s are 24 plus 9 8s are what? 72. And what? Now third row with what? Third column, 4 4s are 16 plus 8 8s are 64 plus 9 9s are 81. So we can add this 4 25 plus 16 become what? 45. 10 15 plus 32 become what? 57. 8 40 plus 36 what? 84. It also become what? 57. This become what? 98. This become what? 116. This becomes 84. This become what? 116 and this become 161. See here, the first row is what? 45, 57, 84. The first column is also what? 45, 57, 84. And second row and second column are equal. Third row and what? Third column are equal. So this is equal to what? What is what? A symmetric matrix. So A into A transpose also what? A symmetric matrix. Hence verified. Now see A plus A transpose. So A plus A transpose equal what? This is A plus what is A transpose. Both are same. So we'll add this 2 plus 2 is what? 4. 5 plus 5 is what? 10. 4 plus 4 is 8. 5 plus 5 is 10. 3 plus 3 is what? 6. 8 plus 8 is what? 16. And what? 4 plus 4 is 8. 8 plus 8 is 16. 9 plus 9 is also what? 18. So see, the first row and first column are equal, second row and second column are equal, third row and what? Third column are equal, is what? A symmetric matrix. So what? A plus A transpose is also a symmetric matrix. Now second question. What is A part of the question is what? Prove that determinant A, B, C a plus 2x, b plus 2y, c plus 2z, then x, y, z is equal to what? 0. We have to prove that the value of the determinant is what? 0. Okay, we can do this problem using what? The properties of determinant. Let what know? The given determinant delta is equal to, the given determinant delta is equal to what? It is given that suppose a, b and c, a plus 2x, b plus 2y, c plus 2z, then what? X, y, z. Now we apply the operation. See, R2 changes R2 minus R1. Okay, we apply the operation what? R2 changes R2 minus what? R1. R2 changes R2 minus. So delta become what? The first row A, B, C, no change. Second row we apply this operation. R2 changes what? R2 minus R1. So A plus 2x minus A become what? 2x. B plus 2y minus B become what? 2y. And what? C plus 2z minus C become what? 2z. Okay. And what is the third row? Third row is what? X, y, z. Okay. So it is very clear that the value is equal to what? 0. Why? Because the second row and third row are what? Proportional. See, here x, here it is 2x. Here y, it is 2y. Z and what? Here it is 2z. That means third row and second row are what? Proportional. So the value of the determinant is what? 0. Hence the proof. Now, B part of the question. So what is B part? A is equal to matrix 1 minus 1 2, 0 2 minus 3, 3 minus 2 4. And B is equal to matrix minus 2 0 1, 9 2 minus 3, 6 1 minus 2. First sub question, prove that B is equal to what? A inverse. And second sub question, using A inverse, solve the system of linear equations x minus y plus 2z is equal to 1, 2y minus 3z is equal to 1, 3x minus 2y plus 4z is equal to 2. Okay. Here A and B are what? Two matrices given. A and B are two matrices given. What do you have to prove? We have to prove that B is equal to what? A inverse. We have to prove that B is equal to A inverse. See, A into B. This is a matrix A into what? Matrix B. So multiply the first row with the what? First column. So 1 into minus 2 is what? Minus 2. Minus 1 into 9 is what? Minus 9. 2 into 6 is what? 12. Now first row with the what? Second column. So 1 into what? 0 is what? 0. Minus 1 into 2 is equal to what? Minus 2. And 2 into 1 is what? 2. Now first row with the what? Third column. 1 into 1 is what? 1. Minus 1 into minus 3 is what? Plus 3. And what? 2 into minus 2 is what? Minus 4. Now we can multiply now second row with the what? First column. So 0 into minus 2 is what? 0. Then what? 2 into what? 9 is what? 18. And what? Minus 3 into 6 is what? Again minus 18. Then what? Second row with what? Second column. 0 into 0 is what? 0. 2 into 2 is what? 4. Plus minus 3 into 1 is what? Minus 3. Now second row with what? Third column. 0 into 1 is what? 0. Plus what? 2 into what? Minus 3 is what? Minus 6. And what? Minus 3 into minus 2 is what? Plus 6. Okay. Now you can multiply now third row with the what? First column. 3 into minus 2 is equal to what? Minus 6. Minus 2 into 9 is equal to what? Minus 18. 4, 6 are what? 24. Now third row with the what? Second column. 3 times 0 is equal to what? 0. Minus 2 times 2 is equal to what? Minus 4. 4 times 1 is equal to what? 4. Now at last what? Third row with the what? Third column. So 3 times 1 is 3. And what? Minus 2 times minus 3 is what? Plus 6. And what? 4 times minus 2 is what? Minus 8. Okay. Now you can add this. Minus 2 and minus 9 become minus 11. Plus 12 is equal to what? 1. Minus 2 plus 2 is equal to what? 0. 1 plus 3, 4. 4 minus 4 is equal to what? 0. Now 18 minus 18 is what? 0. 4 minus 3 is equal to what? 1. Minus 6 plus 6 is equal to what? 0. Minus 6 and minus 18 become minus 24. Plus 24 is equal to what? 0. Minus 4 plus 4 is equal to what? 0. 3 plus 6 is 9 minus 8 is what? 1. So we got now 1 0 0 0 1 0 0 0 1 is what? An identity matrix. So A into B is equal to what? I. A into B is equal to I. Similarly, we can prove that what? B into A is equal to also what? I. So A into B is equal to B into A is equal to I. That means what? B is equal to what? A inverse. B is equal to A inverse. Hence the proof. Now the second sub question now we have to solve the given system of equation. See, what are the equations? X minus y plus 2z is equal to 1. 2y minus 3z is equal to 1. And what? 3x minus 2y plus 4z is equal to 2. Okay. So, this system of equations we can write in the form of what? Ax is equal to b, where A is equal to what? The matrix with the coefficients, and x is what? A column matrix with the what? The variables, and b is what? The constants, matrix constant. Okay. Now we can write now x is equal to what? A inverse into b. To find the solution, the formula is what? X is equal to A inverse into b. The A inverse is already got. What is A inverse? A inverse is equal to b. We already proved that A inverse is equal to what? B. So this is what b. So we got A inverse into what? B. What is B? B is the matrix 1, 1, 2. Okay. So x is equal to A inverse into B. A inverse into B. So we multiply minus 2 times 1 is what? Minus 2. Plus 0 into 1 is what? 0. Plus 1 times 2 is what? 2. Then 9 times 1 is 9. 2 times 1 is again 2. And what? Minus 3 times 2 is what? Minus 6. Then what? 6 times 1 is 6. 1 times 1 is 1. And what? Minus 2 times 2 is what? Minus 4. That is minus 2 plus 2, 0. 9 plus 2, 11 minus 6 is 5. And 6 plus 1, 7 minus 4 is what? 3. So we got x is equal to the matrix 0, 5, 3. Okay. In the matrix x, the first element is x. Second element is y. And third element is what? Z. That means what? That means the value of x is what? 0. The value of y is what? 5. And the value of z is equal to what? 3 are the solutions of what? The given system of equations. Now third question is a very simple question. If A is equal to matrix A1, 1, 0 is such that A square is equal to I, then A equals dash. What is the value of the A? See, it is given that what now? A square is equal to I. So A square is equal to A into A. Okay. A square is equal to the matrix A into matrix A. So that's equal to, see, A into A is what? A square plus 1 into 1 is what? 1. A square plus 1. Then what? A into 1 is A plus 1 into 0 is what? 0, 1. Similarly, 1 into A is what? A plus 0 into 1 is what? 1. So it is A only. Then what? 1 into 1 is 1 plus 0 into 0 is what? 0. So only 1. So we got what? A square is equal to the matrix A square plus 1 A 1. Okay. But given that what? Given that A square is equal to I. So A square is equal to, given it is I, it is an identity matrix 1, 0, 0, 1. So compare these two matrices, we get what now? A square plus 1 is equal to 1. A is equal to what? 0. Again A is equal to 0 and 1 is equal. So we get what? A is equal to 0. So we get what? The value of A is equal to what? 0. Now question number 4. What's fourth question? If A is equal to matrix 1, 3, 4, 1, then find determinant of what? 3A dash. Determinant of 3A dash. See, determinant of 3A dash is equal to 3 square into what? Determinant of A dash. Why? This 2 comes now. Given that it is a 2 by 2 matrix. Okay. A is what? A is a 2 by 2 matrix. A is a 2 by 2 matrix. So, determinant of 3A dash is equal to 3 square. This 2 comes what? Order of the matrix into what? Determinant of A dash. So what is 3 square? It is 9. Determinant of A dash is equal to what? Determinant of A. We already learned that determinant of a matrix is equal to what? Determinant of its transpose. Okay. So dit A dash is equal to what? DTA. So 9 times, what is DTA? DTA is equal to D to what? 1, 3, 4, 1. Because given what? It is 1, 3, 4, 1. That's equal to what? 9 into 1 is 1 minus what? 4, 3 is 12. So what is 1 minus 12? It is minus 11 into 9 is what? Minus 99. Okay. So the answer is what? Minus 99.